Hello everyone, and welcome to 7th grade Math Module 1, Ratios and Proportional Relationships. In this video, we're looking at Lessons 3 and 4, Identifying Proportional and Non-Proportional Relationships in Tables. Our learning goal is to make sure we can create and analyze a table of values for both a proportional and a non-proportional relationship. This will help us to master Standard 7.rp.2a, which is to decide whether two quantities are in a proportional relationship. We don't have any new terms that we need to learn in this lesson. We will be going over and using what we already know about our constant of proportionality. Remember that we use the letter K to represent our constant of proportionality, and that we can use our y divided by our x to find what our constant of proportionality is. When we're solving for a missing number using our constant of proportionality, we can either plug the numbers that we do know into that equation, or we can use our fact family triangle that show the relationship between k, y, and x to help us find the one that is missing. Mark recently moved to a new state. During the first month, he visited 5 state parks. Each month after, he visited 2 more. Complete the table below and use the results to determine if the number of parks visited is proportional to the number of months. In order to complete the table below, I need to go back into the problem to find any information that will help me see the relationship between the number of months and the number of state parks. So I notice, and I highlighted in yellow, that in the first month he visited 5 state parks. So on my table where there's number 1 for months, I can put the number 5 for state parks. I then highlighted in purple that each month after he visited 2 more. That lets me know that every time the number of months increases by 1, my number of state parks will increase by 2. So when I go from 1 month to 2 months, I will go from 5 parks to 2 more, which is 7 parks. When I go from 2 to 3 months, I will go from 7 parks to 2 more, which is 9. After that, in order to go to my next number, I see that I'm missing the number of months, but the number of parks that comes after 9 is 23. I know I need to keep increasing my number of parks by 2 each time the months go up by 1. However, 23 is much more than 2 months past 9. So I have 2 strategies I can use to try to find the number of months that will go with 23 state parks. The first strategy that I can use is I can draw a separate table and extend this out going month by month until I find at what number month I have 23 state parks. Think of it as counting up by our 2 state parks each time and then keeping track about how many months went by for that. The other strategy that I can use is I can find the difference between the 23 and my starting amount of state parks, which was 5. When I do that, I'm left with 18 parks that were visited after the first month. I know that after the first month, we only visited 2 parks a month, so I can take those 18 parks we visited and divide it by 2 to figure out how many more months we had to travel to get to 23 parks. So when I do 18 divided by that 2, I find out that it had to have been 9 months after the first month. Since it was 9 months after the first month, I just add on that first month to find out that we got to our 23rd state park during the 10th month. Now that we've completed our table, we can use our results to determine if the number of parks visited is proportional to the number of months. I highlighted in our word problem in red the keys that let me know whether our months or state parks would be our x or y part of our constant of proportionality. Since number of parks came before the words proportional to, I know that it's our y value. Since number of months comes after, I know it is our x. So all I need to do is take my y values from my table and divide them by my x values and see what the unit rate is, or my constant of proportionality. If they're all the same, it's proportional. So I can start by dividing 5 by 1 from my ratio for my constant of proportionality, and it equals 5. When I do the same thing with 7 divided by 2, I get 3.5. So right there, I can already stop checking the rest of my ratios because I can see that this is not proportional. They do not have the same unit rate. They do not simplify to the same ratio, so these are not proportional. If I checked the rest of them, I would see that they all have different ratios to represent the number of parks visited per month. So this is not a proportional relationship. What does this video make you wonder about making tables from word problems? What does it make you wonder about determining if tables are proportional? Write down your questions so you don't forget them. Then you can try to find answers online or ask a classmate or a teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.